Right, the temperature of a cup of tea in 2 minutes after it was placed on a table in a room is modeled by the equation the temperature is 18 plus 65 E minus T over 8, where T is greater than 0. According to the model, find the temperature of the cup of tea when it was first placed on the table. So when it's first placed on the table, T is going to be 0. So the temperature is going to be 18 plus 65 minus 0 over 8. And if you type down the calculator, this bit here would be 0, e to the minus 0 is going to be 1. So we would have 65 times 1 plus 18, and that comes to 83 degrees centigrade. Okay, part B. The value of T to 1 decimal place when the temperature of the cup of tea was 35 degrees. So when the cup of tea was 35 degrees, we're trying to find the value of T. So we have 35 is 18 plus 65 E minus T over 8. So we're trying to make T the subject. So to make T the subject, we're going to look at this. So we would have 35 minus 18 divided by 65. That would give us E minus T over 8. And then to do the inverse of Euler constant, we're going to do the natural log. So we do natural log of both sides. So ln of this side. So we're going to have T minus T over 8 is going to be ln 17 over 65. Now T is going to be ln 17 over 65 times that by minus 8, and that would give us 10.7, roughly 10.7 degrees. So that's the answer for part B. Part C. Explain why the temperature of this model of the cup would not fall below 15 degrees. And the reason is because as the time goes by, if it's in a room, it means that it has to adjust to the room temperature. So it can't go below the room temperature. But we need to just prove that is the case. So we're going to have, let's say, as T goes to infinity, so lots and lots of hours later, what is going to happen is that E minus T over 8 goes to 0. And that means our equation would then look like this. So we would have A is 18 plus 65 times 0. So therefore A is going to just be 18 degrees. Now as you can see that it means that the asymptote is actually close to 18. So we could say that it would not go below 15 degrees because at that point A is always going to be around 18 degrees. Now part D, we've got the temperature mu degrees of a second cup of tea minute after it was placed on a table in a different room is modeled by the equation mu equals A plus B E minus T over 8, where A and B are constant. Figure 2 shows a sketch of mu against T with 2 data points that lie on the curve. The line L, also shown in figure 2, is the asymptote to the curve. Using the equation of this model and the information given in figure 2, find an equation for the asymptote. So what that means is we're going to use the 2 points we've been given on our curve and use the equation. So we have that when, let's do this, so when t is equals to 0, mu was 94. And on the other side, when t was 8, we have mu was 50. So what we're going to do is we're going to create two simultaneous equations and then solve it to find A and also solve it to find B. So the first part, the equation is mu equals A plus B E minus T over 8. So we have mu is 94 equals to A plus B. If this is 0 here, that makes it e to the power of 0, which is just 1. So we would just have 1b on that side. On the other side, we have mu is a plus be minus t over 8. Now, mu is 50 equals to a plus b e minus 1, because 8 over 8 is minus 1. So minus 8 over 8 is minus 1. So we have our two simultaneous equations. Now there are two ways of solving this. I'll show you both methods and then you just choose which method you prefer. So I could just say that I'm going to rearrange or make A the subject and then use that to substitute into the second equation. So let's call this equation 1 and let's call this equation number 2. So I could make A the subject. So here I could say, all right, A is 94 minus B. So that's equation 3. I'm going to substitute equation 3 into 2. So now I'm going to have 50 equals A plus BE minus 1. So that's going to be 94 minus B plus BE minus 1. And that equals to 50. I could then factorize the B. So let's have 50 minus 94 equals minus B plus BE minus 1. We could take out the B, so factorize out the B. So we would have, well, it depends on how you look at it. You could take out B or you could take out minus B. I'm just going to take out B all on its own. So we're going to have minus B is 1 plus, actually this will become a negative E minus 1. Or you could take out the B and then you would have minus 1. Let's see if that works as well. So, or you could have B minus 1 plus E to the minus 1. Okay, so any one is fine. So we would have 50 minus 94 on this side. So B on its own is going to be 50 minus 94 over minus 1 plus E minus 1. Just get a calculator to work that out. So 50 minus 94 over a negative 1 plus E to the minus 1. And that gives us 69.606. Now we still need to work out A, and remember A is 94 minus B. So A equals 94 minus B, and that will come to 24.4. Now remember in the earlier example, when we had A was like 18, the asymptote was very close to 18, so the asymptote was 15. So again here, the line L is going to be any number below 24.4. So I'm just going to just write that down. So any number that's below 24.4 is going to be where the asymptotes are. So I'm just going to put it as 24.4 for now. The second way you could solve this equation is by using this equation. So the second equation was 50 equals A plus BE minus 1. You can times the whole lot by E. So we would have 50E equals AE plus B. Now E minus 1 times A would just be 1. So now if we rearrange that, B is going to be 50E minus AE. We can then substitute that into equation 1. So let's call this equation 4. So equation 4 into equation 1, we're going to have 94 equals A plus B. And remember, B is this. So that's the value for B. This is B. Now we're going to make A the subject. So A is going to be 94. Actually, before we can make A the subject, we could just factorize A out. So A, we have 1 minus E plus 50E. Because we've got A here and we've got A here. So literally, if we factorize A out, we've got 1 minus E plus 50E, and that's 94. Now, we can now make A the subject. So A is going to be 94 minus 50E over 1 minus E, and that would give us the same answer as before. So again, the equation of the asymptotes, L, any values that's really below 24.4 would work. I will leave it as 24.4, and that's our asymptote. All right, thank you so much.